Today, we're going to break down a playbook for building AI applications that aren't just cool demos, but are actually robust, reliable products. We're going to get into how you go from just a simple idea all the way to production-grade AI, using a framework that was literally built on the front lines. Okay, so this is where everything changed. I mean, look at this. The jump from GPT 3.5 to GPT 4 wasn't a small step. It was a quantum leap. On the uniform bar exam, a test it had never seen before, GPT 3.5 was in the bottom 10th percentile, a total failure. But then GPT 4 comes along and scores in the 90th. That one leap meant that for the very first time, AI could handle really complex professional tasks. It made a whole new world of applications possible. But this incredible new power, it created a huge new challenge. How do you actually harness it reliably? Well, the answer is this proven 5-part playbook. We're going to cover everything from the high-level strategy to the real nitty-gritty of prompt iteration and some pro-level engineering tricks. Right, so that massive jump in performance, it wasn't just some academic score. It was the green light, the signal to go ahead and build CoCounsel, the very first AI legal assistant. For a decade, lawyers had been asking for a tool just like this, and the answer was always the same. That's impossible. But with GPT-4's new skills, the impossible, well, it suddenly became achievable. So you've got this incredibly powerful model at your fingertips. Where do you even start? The biggest mistake people make is they immediately start trying to write a prompt. But the professional approach, it starts way earlier. It starts with a 3-step framework that's all about the end goal, not the AI itself. First, you have to obsessively define the perfect user experience. What does success actually look like for the person using your tool? Second, you ask this really crucial question: how would the absolute best human expert on the planet do this exact same task? And third, you break down that expert's process into tiny, separate micro-steps. Each one of those steps, that's going to become either a line of code or a prompt. To make this a little more concrete, let's just stick with the CoCounsel example, specifically its legal research tool. So what does that expert process really look like? If you went to the world's best legal researcher and asked them to solve a case, what would they actually do? What's so fascinating here is the hidden complexity it reveals. An expert doesn't just type one thing into a search bar. No way. First, they clarify the question to make sure they understand it. Then, they brainstorm dozens, maybe 50 or more, different search queries to attack the problem from every possible angle. They read everything, every single page of every result, and only then do they synthesize all of that into a coherent answer. That detailed process right there, that is the architecture for your AI application. All right, so you've got your micro steps. Let's say one of them is formulate a good search query. Now comes the hardest part. This is the part where most people just fail. How do you make a single prompt for that one little step work reliably every single time? The method is surprisingly simple, but man, it demands serious discipline. You write your best initial prompt. Then you create a small set of about 10 evaluation cases, or evals. You run your prompt and you just iterate relentlessly on the instructions until it passes all 10 of those tests. Only then, once you've passed 10 out of 10, do you scale up, creating hundreds or even thousands of tests based on real-world user behavior to make it absolutely bulletproof. And this right here, this is the great filter. The first prompt you write might pass, say, 6 out of 10 tests. The amateur looks at that and says, well, I guess AI just isn't reliable, and they give up. The professional sees the 4 failures and understands that their job is to get that number to 0. Pushing through from 60% all the way to 100%, that's what separates a cool demo from a real product. And that's the crucial point. There is no magic formula for the perfect prompt. The secret is an obsessive, relentless commitment to iteration. It's the willingness to just grind on a single prompt for weeks, if that's what it takes, until it's nearly perfect across thousands of different scenarios. But here's the twist. Even a perfectly engineered prompt can fail. Why? Because the quality of the information you feed the AI, what we call the context, it matters just as much, if not more, than the quality of your instructions. Think of every prompt as having 2 parts. You've got the instructions, which is what you tell the AI to do, and then you have the context, which is the raw material you give it to work with. This could be the user's question, a 1,000-page document, or, the current state of a chess game. And this really gets to the heart of the problem. If you tell an AI to summarize a document, but you give it a messy, unreadable scan that's full of gibberish, you can't blame the AI for a bad summary.
That old saying, garbage in, garbage out, is more true for AI than almost anything else. A lot of the time, your problem isn't prompt engineering at all. It's a data or retrieval problem. So once you've mastered the expert framework, the prompt grind, and your data quality, now you can start using some advanced tricks to optimize for speed, cost, and accuracy. These are the hacks that take a system that works and make it truly production ready. Here are a few quick wins for you. For fast classification tasks, force the AI to output just a single word, like true or false. It is incredibly fast. For easier automated testing, have the AI give a numeric score before it gives its written explanation. And this one's super important, always favor breaking a complex job into multiple simple prompts instead of one giant complicated one. Simpler tasks just fail less often.
And for the ultimate level of reliability on a specific repetitive task, you can use a technique called reinforcement fine-tuning. Now, unlike old methods that required thousands of examples, this allows you to create a highly specialized expert model for each little microstep in your process, using as few as 50 examples. This can just dramatically improve your accuracy and consistency. And remember, there's no rule that says you have to use one model for everything. Smart engineering means using a portfolio of models. Use the most powerful, most expensive models for the heavy-duty, complex reasoning. But for simpler tasks like routing or classification, switch to smaller, cheaper, and faster models. This saves a ton of money without sacrificing quality where it really counts. So the key takeaway here is this. Building a powerful, reliable AI application, it's not some mystical art. It's not about finding some secret magic prompt. It is a discipline, a rigorous process of design, engineering, testing, and just relentless iteration. The power of these models is here. It's ready to be used. But to truly harness it, you need a system and a commitment to engineering excellence. So the real question isn't what magic prompt will you find, it's what rigorous process will you build. That's our explainer for today. Thanks for watching.